All right, let's say that you are, let's say that you want to change base for a logarithm. You have log base b of something x, and you want it to be base something else. Like, let's say you want it to be log base c. Well, what you can do is use the thing called the change of base formula that does allow you to change from one base to another. So what you get is log base c of x, but then divided by log base c of b. So whatever your original base was, you have to divide by the log of that, okay? And then you can have any base you want. So you can convert from any base to any other base, as long as these b's and c's are both positive numbers. Okay, so let's go over a proof of this information, okay? A proof of this fact. So the way you can do that is you can start with log base b of x. Let's start with what we've got. Let's say that equals y. Okay, whatever that is, it's equal to y, all right? And we want to show that y can also be rewritten in this format over here, the log base c of x divided by log base c of b. The way you prove this is you start by rewriting this as an exponential. And the way you do that is, b to the power of y equals x, right? So you rewrite it in the exponential format by swapping the x and the y, swap the input and the output. So now we've got it written in exponential form. Now what we can do is take the log base c of both sides of the equation. So we're taking log base c of both sides. This is valid because log base c is a one-to-one function. We can do both sides of an equation, and therefore it's equivalent to what we started with. Right? It's something that can be inverted. So now we've got a log base c introduced. Now we're going to use one of those other properties of logarithms to take the power from inside this log on the left and pull it out and turn it into a multiple on the outside. And so now we've done that. Now we're almost there. Now all we have to do is divide by the log base c of b to get y is log base c of x divided by log base c of b. And since y was equal to log base b of x initially, and now we've shown that that same y is equal to log base c of x over log base c of b, therefore log base b of x here is equal to the log base c of x over the log base c of b. And that completes the proof. So a quick example of how you use this. If you have something like log base 7 of 10, what you can do is rewrite this in any log you want. And since we've got 10 on the inside, let's rewrite it with a common logarithm. You can rewrite it as common log base 10 of 10, but then divided by the log base 10 of 7. Log base 10 of 10 equals 1, so this would be like 1 divided by common log of 7. So there's an example of applying it, all right? Now, there's lots of different situations you might want to apply it. Like, for example, if you've got the common logarithm of x, you can always rewrite that as the natural log of x divided by the natural log of 10. And it turns out in some situations, the natural log is the most convenient logarithm to use. Like, for example, when you get to calculus, sometimes the natural log is what you want because it's just the most convenient one. It has the most convenient rate of change. It's easiest to find. And so we might want to rewrite everything in terms of the natural logarithm. And you can do that here. Whatever your log is, log base b of x, you can always write it as natural log of x divided by natural log of the base, the original base, whatever that b value was. So those are kind of situations for like how you might want to use the change of base formula to your advantage. Okay, so that's that.